Hello everybody and welcome to the first Lee's Artificial Intelligence Group meeting. Mr. Howe asked me to start off today with a short introduction to the concept of AI and what we really mean when we say artificial intelligence. Now, I'm not going to spiel on about the super nitty-gritty technical details, since what we're here for is an understanding technical enough for us to figure out new ways we can implement this incredible tool in our everyday life at the Lees. Artificial intelligence is a very open term, but it's usually defined as developing computer systems that can perform tasks which typically require human intelligence. Okay, but what does that actually mean? The tools you're all probably familiar with, like ChatGPT, DALL-E, and perhaps even Google's Bard, are all forms of generative AI. These systems work by being trained on extremely large sets of data, called datasets. A machine learning tool will be given a set of rules and a set of data, and it will have to link rules and patterns to the data. Think of it this way. If you gave the machine learning tool a dataset full of pictures of people, half with blue eyes and half with brown eyes, and you also gave the tool each person's respective genetic makeup, the resulting AI would be able to determine if a person would have brown eyes or blue eyes, just with their genetic makeup. The AI has zero concept of human biology, and it doesn't know what genetics are, but it can simply identify a pattern and use that in new scenarios. We call this a neural network, and it works in a very similar way to the way our brain does, capturing data and linking it to other data that's already been captured. Over time, these neural networks can become pretty good at generating their own data, based on the information they've been fed. This leads us to our present day, with what is known as a large language model. Effectively, an AI that has been trained on billions of pieces of human writing, and can now generate its own. The most popular example of this being ChatGPT. Now, it would be unfair, of course, to only talk about large language models, since these only refer to the text-based tools. Image generation tools are known as large visual models, and tools that can perform tasks for you are large action models. This technology is evolving day by day, and it keeps getting better and better. For example, only a couple weeks ago, Google released the latest version of their large language model named Gemini, and it's incredible. The headlining change is not an increase to its dataset, but rather an increase to its context window, now to 10 million tokens, compared to GPT-4's measly 128,000. What does that actually mean? Well, you may have pasted a document into ChatGPT and found that it can't accurately pull from all of it, and it might forget earlier parts of your conversation if it's quite long. This is because of ChatGPT's low context window, at around only 16,000 tokens for the normal ChatGPT, known as GPT-3. But with Google's new Gemini, it can remember and pull from up to an hour of video, 11 hours of audio, or up to 700,000 words. This kind of stuff could be game-changing in education, where a model like Gemini could scrape through multiple textbooks and give you the most accurate answer to a question according to your exam board specifications. Now finally, just before I go, I want to surprise you all with something. Now, the most diligent of you may have noticed that my eyes in this video may seem a bit off at some points. And that's because they've been entirely augmented by an AI known as NVIDIA Broadcast. This tool works live on my computer while I'm recording, and augments a version of my eyes which face exactly towards the camera, so it doesn't look like I've been reading a script. This tool is so good that you may have not even noticed that I've been using it in this video. That just goes to show that AI is not just the future, but it is indeed happening right now. So it's an imperative that we discuss it. Thank you.